Hello, everybody, and welcome to the afternoon sessions here at the Battery Innovation Days. My name is Wouter IJzermans. I'm the Executive Director of BEPA, the Batteries European Partnership Association, so the private side of the European Partnership BAT4EU. We combine research members and industry members to join up and advise the EU on their R&I priorities for batteries. As such, we are also looking a lot at actually how they need to be implemented, where they need to be implemented, and what kind of research needs to come from that. And this afternoon, we're going to look at the battery R&I for the automotive industry. Of course, it's one of the main drivers, I would say, for the main driver for the R&I of batteries over the past years. So it's a really good topic to dig into, and we have a really good lineup coming up. We will start with a presentation from Stefan Neugebauer. He's from BMW as Director of Global Research Corporation, but he's also the chairman of AirTrack and of ECVIA420, which is the private side association representing industry and research in the 2.0 partnerships directing R&I for road transport. Then we will have a short panel discussion with Stefan and Alexander Roberts from Coventry University and Luis de Prada from EOCAR on really the R&I priorities for the automotive industry. And then after a short Q&A, we will move forward with a second panel discussion, which is around the infrastructure challenges ahead to deploy electric vehicles. And there's already quite some interest in the topic shown as well yesterday in the stationary session, but we're going to look at it more in depth today. Yeah, first up is the presentation of Stefan. Stefan has had various positions within the BMW, being in charge of the development of various technologies and vehicles. And he's now Director of Global Research Corporation at BMW, but also Chairman of AirTrack and ECVIA420. So he's really plugged into the European R&I landscape for automotive industry. Really looking forward what Stefan can tell us on this, and looking forward to your presentation, Stefan. So please take it away. Stefan, can you hear us?
Yep. Thank you very much, Wouter. Thank you. I'm really happy to give you some insights for the battery needs for the automotive industry. So we can move on to the next slide, please. The roadmap of battery needs for automotive industry, or let me say some perspective from the automotive industry. What do we really need? If we move on to the next slide, please. The automotive sector is committed to a carbon neutral road transport system. And we are committed to do this in a life cycle assessment. So the electrification of road transport is the most important measure for the decarbonization of transport and for road transport in specific. So there's no doubt, electrification is the most important measure. And this means that the XEV will become the new normal. XEV, what does it mean? XEV, these are, and you can see it on the slide, these are the battery electric vehicles for sure, but these are also the plug-in hybrid electric vehicles or the fuel cell electric vehicles or the hybrids, when you think also about commercial vehicles. And what is to all of these vehicles? All these vehicles, they need batteries. All these vehicles need batteries. So it's really true that the XEV, this means battery electric vehicles, plug-in hybrid vehicles, fuel cell electric vehicles and hybrids, they will become the new normal, and all of them, they need batteries. So that is clear that here we have a huge challenge to do this in the right way. And so we can move on to the next slide, please. The batteries for the xEV usage, it is a growing competition. And we have some specific challenges of batteries for the automotive application. And this means at the end, we have we need a cumulative performance. So it's not only that we need one performance in a specific, we need a cumulative performance. For sure, we need energy density. It is clear because we want to use the battery for the traction of a vehicle for a longer distance. So energy density is needed because we need to store a lot of energy in the battery. Then for sure we need power density because road transport is a dynamic transport. We need power for sure. And then we need charging rate. Why? Because charging is always a bottleneck and no user wants to wait until his battery is recharged. So charging rate is not only a matter of comfort, it is a matter of acceptance for electrification of road transport. So charging rate is important. And then we need cyclability in order to have batteries and to produce batteries and to use batteries in a sustainable way. And then we also need to think about the lifetime of the battery, including the second use after the use phase in road transport. So you can see we have cumulative performance needed, and the automotive industry is a global industry. We are not a national industry. We are not a continental industry. We are a global industry. This means that batteries, they will be purchased in a global competition. And this is good because we believe in competition, and competition always brings a benefit to the citizens, to the society, to all actors. So this means that batteries manufactured in Europe, they need to be competitive in terms of functionality, in terms of costs, in terms of sustainability. And this is very important to understand because no one in Europe, or nearly no one in Europe, will buy a battery because it is produced or developed and produced in Europe. No, this is not the case. The customers, they buy things because there is a good functionality, because the price is fair, and for sure some customers, not all, but some, for some customers, the sustainability is very important. So this is very important to understand that the European battery area is in a global competition. So if we want to play an important role in this competition, then European batteries must be better than other batteries. That's it. That's it. Only to say we are European is not enough. So if we move on to the next slide, please, you can have an overview about requirements from the automotive industry. First of all, we are working on electrification that meets mass market. And this is what we need to do in order to decarbonize the road transport as fast as possible. We need to meet the mass market. And what is most important for the mass market? It is cost reduction. And you know that the battery itself is one of the most cost-intensive component in the vehicle. So cost reduction is a major issue. And then in order to have a good vehicle, because the consumers, they are not buying a battery, they are buying a vehicle. For sure, we need the high integration of the battery into the vehicle. On the other side, we need the recyclability and partial repairability. That there are um, um, aspects which seems not to fit perfectly together, but that's quite normal in our business that we have to find an optimum for this. And so we have to focus on the essential requirements for vehicle use and second life and life cycle assessment. And this is important to focus on the essential requirements, because you can write down a list with a lot of requirements for batteries from any perspective and so on and so on. And if we do so, then at the end, the battery, nobody will be able to pay for it because it's too expensive. So we really would like to ask you to focus on the essential requirements. The next point is that safety is a paramount. This is something I think we do not need to explain. It's a precondition. That's it. Whatever we do in Europe, it must be safe. That's it. Full stop. The third point is the circular economy. In our point of view, circular economy will become a standard. This means we should try to reduce the use of materials as much as possible. If we cannot reduce, we need to reuse the materials or the components as much as possible. And if this is not possible, when we should try to recycle it in a sustainable way. So circular economy will become a standard, especially in the premium market, but I think not only in the premium market, it will become a standard for nearly all segments. And then we should try to establish a local, this means a European supply chain. This is highly welcome from the automotive sector. For sure, we are in a global competition, but to have a local European supply chain, and we all know the situation right now, this means that it is highly welcome to be a little bit more independent from other areas in the world. And this is not a contradiction to the global business. And then last but not least, research. Research alone is not enough. Research is important. Research is a precondition for innovation. But innovation is much more than research. Europe has to become a world leader in industrialization. And I was working in different functions in my company, and I learned that industrialization is really a complete different challenge compared to research. So we need to do both. We start with research, and in parallel, we have to work on the industrialization. And at the end, Europe needs to be successful to be a world leader in industrialization of battery technologies. So you can see that this is highly complex, and how can we do so in research? And therefore we are very happy that the European Commission and institutions, they set up several partnerships on this. And so we can move on to the next slide, please. Here you can see a picture for some of maybe the most important partnerships in this area. You can see the Towards Zero partnership, and you can see clean hydrogen and the battery partnership. And when we start with the battery partnership, you can see that the battery partnership is focused here on the first steps for materials and the design of the cells and the battery component itself. And when it comes to the integration, then the Towards Zero partnership gets the lead. And if we're talking about the second use and recycling, then it goes back to the area of the batteries partnership. And it's the same logic that we have with the clean hydrogen partnership. And therefore you can see that collaboration between the partnerships is needed, and that's good. And we are able to do so, and we are willing to do so. And for a private sector, it's quite normal that we have this cooperation. And therefore, we are very happy that this cooperation will now also start in the European research program with this cooperation between the Towards Zero partnership, clean hydrogen, and batteries partnership, but not exclusively. There are many other collaborations ongoing. So I will stop here, and I hope that I could give a short a first start for the discussion, and I'm happy to get your questions or to join the discussion. Thank you very much.
It was a very interesting look into to the needs from the road transport sector, and to see really, yeah, like what are the basic needs compared to what we would like to have if we want to have everything at the full level. Then we get on something that we cannot afford, and as you said, affordability is one of the key requirements. So let's move on to the panel discussion to discuss all this. Stefan will be joined by Alexander Roberts, who's an associate professor at Coventry University, and Luis de Prada, the research program manager at EUCAR, both also heavily involved in battery research. Alexander more from the actual battery and cell side, and Luis coordinating the EUCAR research program here within the European R&I landscape. So welcome to have you three all here. Stefan, just to start off with you after your presentation, you can all turn on your cameras if you want, and we can see your for the discussion. Stefan, just to follow up on your presentation, you showed us the 2.0 partnership and clean hydrogen and BAT4EU. How we also have the partnership on automated driving, CCAM. AirTrack is also involved in that partnership. How do you see changing business model influence what you've just presented? Will it change a lot, or is it just something that we will have to take into account at some point, but not really a driving force?
Thank you very much for this question. So as far as I understood, your question is, will the collaborative, connected automated driving have a big influence on the electrification of road transport or the batteries itself? Yeah. For sure, there will be some improvements of the road transport system by connected and automated driving, for sure. But for the vehicle itself, I think there will be not so many influences coming from digitalization, but some are there. If you think about the charging and how to charge and how to plan the charging, this is something which will be done. The question about the ownership of the vehicle, I think, is not that important, because in any case you need a vehicle, in any case you need a battery, and you need to charge it. This is absolutely independent from the ownership. So there will be some influences from connected and automated mobility, but not that much here in this field.
Yeah. Thank you. Let's move on to Alexander. Alexander, you have been working on battery technology for quite a while. What you saw the list of requirements that we have to work on multiple aspects of the battery research. What's your own background in this, and which of those issues have you tried to tackle?
Well, my background is, I mean, I've come from the materials side initially, but moved towards developing some of the engineering aspects and tailoring what we find in the laboratory and moving it through to sort of prototype cells. So a particular focus on fast charge and the requirements in there. So this comes down to looking at things such as, do we have an anode material that's capable of accepting the charge on the materials level? Because of course fast charge is a very broad term. Are we talking about a 2C charge? We're talking about a 20C charge, and they have very, very different requirements in there. But moving on from there, assuming that we have an anode material that can accept the charge at this rate without any safety considerations or any lifetime considerations being brought into this, it then becomes a factor of mitigating resistance and mitigating heat. So I spend a lot of time looking at the design and the engineering of the cells to see how we can best achieve this. Focusing predominantly inside the cell, but also with a consideration around the cooling strategies that will be used for the cell on the external.
Yeah, so paramount of safety, as Stefan said, but also looking at the charging performance there. So
yes,
yeah, covering both those fields. We got a question in the chat, and it's also something that I've been wanting to ask you about, Alexander, because you've been working in the UK with the Faraday Institute to really bridge academia and industry as well. So we've got a question. In your opinion, what can we do for laboratories to be closer to manufacturers and really achieve a better delivery on this? It was a question by Nuri Mattia.
Okay, yeah. So yeah, thanks for the question. A very, very good question. I'm quite fortunate in my position because I have a industrial fellowship from the Faraday Institution, which effectively buys out a lot of my time to work directly with a specific company. And this sort of thing it's a wonderful thing from the view of the academic, because you get a lot of experience in the business aspects that you wouldn't be exposed to, but also it allows the industry to access specific facilities and specific skills. So when we look at this, if I was looking from an industrial viewpoint, I would be looking towards the possibility of industrial sponsored professors or associate professors or positions like that. Longer term research, I think, is very, very important, and building that close collaboration, because very often we work closely together with a partner on a research project, but we then get this very specific area that may be higher risk, that needs some different skills to go through, which takes time. From an academic viewpoint, I think there's a real need for the importance of real world impact to be recognized on par, and in fact, more importantly than maybe publication, for example, the metric that academics have traditionally looked at. And I know that there is a big push towards this, which is a very, very positive thing. Yeah. One final thing on this is, let's pick the laboratories that have a specialization in the required area. There are some very, very good laboratories around Europe in academia with some very specific capabilities. I would say target those laboratories. Let's go to the academics who have the specialization in one area, and maybe work with a broader range of people rather than just one or two.
Yeah, okay, that's three very different viewpoints, but three very good points that you made. It's also a good move to now go to Luis de Prada from EOCAR. Luis, you're very active in all the partnerships that were just presented. You're very active in BEPA, which we thank you for, but also in 2.0. How do you, as a representative from the vehicle industry, bridge that gap towards the academia to get the projects towards a higher level?
I would like to elaborate a little bit on what Alexander has said. I fully agree with him. I mean, a longer collaboration and a larger collaboration will benefit both, especially because, it is important for academia to maintain the low levels of TRL and to research in basic areas. But it's important to have the guidance also for the industry from the very beginning, so this can achieve industrialization. So we can have a quick, fast pace from the lower TRL levels to the larger TRL levels. I would also like to highlight the relevance of having in mind from the early stages as well the possibility of industrialization, who was also mentioned at the beginning by Stefan. It's the ultimate goal to be able to reach to products and to have an impact on the day-to-day life and on the industry, and of course to achieve the Green Deal objectives at the end of the day. There is also another thing that I would like to highlight, that this should not only be focused on academia and industry. We should try to involve as many stakeholders as possible, because this challenge is an holistic one. It's huge, so it should be addressed in an holistic way. I mean, we are not going to only solve it with one technology. We need also clean energy. We need the availability of the energy. We need the involvement of the end users. We need the involvement of the authorities. So it's really a large and complex challenge we have ahead. And a first step could be, really strengthening this cooperation with academia, but not not only limiting to this area, but extending this, to further areas.
Yeah, I'll definitely take that on board for the partnership, and I'm sure that Stefan will do as well. Like, not only we have now gathered academia and industry in these partnerships, but we need to use these partnerships as a tool to reach out to the other stakeholders. So yeah, fully agree with you there. Got another question from Stefan coming in the chat, harking back to the connected driving issues. Like, for smart functionalities going into the vehicles, like the sensors, you still need. Does it have any influence on the power requirements of the car itself?
Thank you for the question. So at the moment, we can see in research and development that the system for connected automated driving needs a lot of electricity, and it is sometimes in the order of magnitude of the power you need to drive a vehicle with low speed. This is not acceptable, and this will be not the case for the future. So in future, the power demand of these systems will go down and have to go down. So at the end, the power we need and the energy we need will be dominated by the driving of the vehicle itself. Just by physics, you have a huge or you have a vehicle with a certain mass, and you have to move it with a driving resistance. So I think in the longer perspective, you can just calculate with the power demand for the driving of the vehicle, for the movement of the vehicle itself, and the subsystems like for connected automated driving, they will be in the order of magnitude much lower than the driving itself. I hope this answers the question.
I think it covered it well. So thank you on that. A little follow-up. I saw a presentation of you recently. I think it was actually at the EU Car event, where you explained the roadmap that AirTrack has been making towards zero fossil fuel. And I think the figure, I don't know, but the top of my head, was like around 35% of European electricity needs will go to EV use in the future. I don't know if you can correct my ballpark figure there, but yeah. So is that still valid then in this sense, or do you think that does that include this kind of energy need for sensors and smart functionality?
Oh, this is included. Excellent that you remember this figure. This figure was the figure for the charging of electric vehicle. The charging of the electric vehicle. If we think also about hydrogen, which will be needed in some use cases, and you have to produce this hydrogen also by using electricity, then the figure is higher. And if you think about renewable fuels, and they will be needed anyway for the existing fleet and for certain use cases, then you can say that around about 50%. It depends on the scenarios and so on. It's very complicated, but have in mind around about 50% of the electricity which is produced today in Europe overall We need around about 50% of this in addition for the carbon neutral road transport. In addition. And we need this in a renewable way, and we need this we need to get access on this by the charging infrastructure, and we need to solve the power peak problems, and so on and so on. So you can say there are a lot of things to do in research and innovation.
I will definitely in the next panel session forward this question to NL to ask what they are going to do on this. We got another question on charging and charging time. I think I will direct this one to Alexander. Do you think that there's like a sort of upper limit to or like an under limit to charging time to have charging done safely and realistically without any thermal excesses? Or is there still so much room to improve, and we haven't even started?
I think, to be honest with you, depending on where you're looking at in the development cycle, I think the answer is yes to both of those. Let me just explain that. I mean, I think we have to bear in mind, what does the consumer want? You know, how long is it acceptable to recharge your car? And I'm not talking, you know, a full recharge. Because if we think about it, how many people with an internal combustion engine will go up and fully refuel the tank every single time? So is it enough to have a 10-minute charge? And what percentage do we need to put back there? So I think we need to be led by what the requirement is by the end user. When it comes to the capability of the cells that are there are cells being developed, there are cells that are coming through that can do very, very fast charging. And by that, I mean some specialist cells that will charge in a matter of a few minutes. Their suitability to the other requirements involved in the vehicle may not be there at the moment, may get there, may not get there. So I think there is a balance there, but there's certainly an awful lot that can still be done to improve these.
Yeah, thank you. Maybe Stefan or Luis, from your side, have you done any research towards the other stakeholders to see what's an acceptable time that we can put as a target? Or
I try to start, and then Luis, I would like to forward it to you, because this is a very, very important question. And when we start, and this was already mentioned, when we start from today's behavior with refueling the vehicle, you don't care about it. You just use your vehicle, and when you see that you need some fuel, you stop and you refuel it. That's it. For battery electric vehicles, this seems not to be realistic. This is not realistic, I think. The normal way of charging a battery vehicle, and the most sustainable way, is to do it with a low power level, to charge it at home, to charge it at work, to charge it whenever the vehicle is parked for a longer time. So this should be the normal way. But this means that we need a lot of charging infrastructure. You can simplify it. We need charging options at each place where the car stands for a longer time. That's it. But in some use cases, you do a longer trip and on the highway, and then you need charging power. And this is the high power charging, and this should be an extraordinary use case. But it has to be solved. And here you will see that for a premium vehicle, premium product, high power charging is very much needed, and people will pay for it. For a mass product, it will take some longer time. So it's hard to say clearly what will be the requirements, and it depends on the segment of the vehicle. It depends on the costs which are people willing to pay for it, and it depends on the grid, because we need to deliver the energy to the charging station, and this will be the bottleneck at the end. So you can see it's highly complex. Yes, high power charging is needed. It should not be the normal use case, and it will be at the end always very expensive, to be absolutely transparent. I hope to be so.
Luis, you want to
yes, I would like to take from the point in which Stefan has just finished. I fully agree in this approach, especially for personal and private mobility, but we have not considered also that there is something called, the movement of goods through Europe, and commercial vehicles play an extremely important role in moving these goods everywhere in Europe. The long distance freight transport in particular will have, if it's going to be electrified, will require extremely fast charging, or at least fast charging. This is also, linking with what Stefan was saying before, highlighting that hydrogen and also e-fuels, can be an alternative, especially in this transition and in the short term. But it is clear that in the long term, we will need, at least for some specific cases, this fast charging infrastructure, which brings new challenges to the table, because of course, if you are driving somewhere from Moscow to Porto, some I don't know, 40 tons of fruits. Well, it should be the other way around. But the way is that you will require this fast charging, because right now you can just fill up your tank in Porto and drive 5,000 kilometers, without needing to refuel. But this is not going to be the case with hydrogen or battery electric vehicles, and this is something to be addressed, and the need to bring this high power to the specific points in which charging will be allowed. So yeah. Absolutely.
Thank you for taking that button. It was actually my follow-up question to ask how it will change for other types of road vehicles. But I wanted to take that a little bit wider. Like if we look at the list of requirements that Stefan presented, are there any differences if we look at heavy-duty vehicles? Do we then what will be more important and what will be less important? I will start with Luis.
That's an unfair question. Everything is important. We need both the movement of good and the movement of people in Europe. So the transport.
Not between one or the other, but not good. But if we look at heavy duty, are there any points like the safety or cyclability which are more important in that sector? That's what I'm saying.
There is one important thing that we have not considered so far, but I think it links with your questions anyway. Is that the requirements will be different depending on the use case. And of course, it is obviously a different, just let's say an urban vehicle in which someone uses daily, which is, I think, considered less than 45 to 60 kilometers a day. That's already a really long distance daily. And of course, the requirements will be completely different, from a commercial vehicles or even a garbage truck, picking up the garbage through the city, needing to carry a huge load, for longer periods of time and most likely daily as well. So, of course, the challenges are completely different, and the requirements in the battery will be as well. I think Alexander can also clarify on this because, power density, energy density, the peak require, the charging times, the lifetime is extremely important, especially for commercial vehicles because they depend on the total cost of ownership. They are a huge investment for logistic companies and they need to recover this investment. And, so of course, there are absolutely different requirements. And I would like to highlight that these requirements can be split up between the performance ones. I think they were mostly mentioned by Stefan in his presentation, but he also touches in a very specific ones, which is the sustainability ones. Because it's not only about having the better, energy density in the batteries. We have to make sure that these batteries do not harm the environment during the manufacturing and also during the recycling or during the use of them. So it's a really challenging and complex, situation in which we have to address every single part. And I think we need an holistic approach for this.
Very clear. Alexander, will you want to follow up on the comments?
It's just basically, I think it's been summarized very, very well there. That it's back to the old adage of there is not one battery that will suit every application. And the batteries have to be developed with that end use in mind. So taking the example of the garbage truck, for instance, straight away we can see, as Luis pointed out, we're going to have some very, very heavy loads there. We're going to be requiring high power bursts. We're probably going to have a fairly large capacity in that system. And if we don't have the large capacity, we're going to have some faster charging. But all of the time, we're going to need the lifetime to come through for this. So I think it's a really intricate problem to look at and one that there is no general solution to.
Thank you. The S word has been mentioned, sustainability, which has also been one of the red threads in this this Battery Innovation Days so far. We had a question in the chat. I think it's from Yosu Sandoya. How do you see the role of automotive producers in the recycling effort? Do you have a role, and what will it be? I see you moving your head, Luis, so I'll give it to you.
Okay, this is a topic that we have from a pre-competitive point of view already discussed. I mean, the recycling industry is fragmented in Europe, especially for the recycling of several components coming from the end of life of the vehicles. This is something that we have to address. I don't think that probably the automotive industry should be in the leading position, because we are not most likely going to become recyclers. But we need to be involved. This is extremely clear, because if we are going to reuse the products coming from recycling, like raw materials, recovered from the batteries, or even some of the components, because they have a still life, usable life, we need to make sure that they are recovered properly, that they are recovered with automotive quality and with automotive quantity. And for this, we have to agree to find them, I don't know, maybe in a standard with the industry and address this complex and extremely complex problem, from a European point of view. I think that is important.
Yeah, and here we can take into the lesson, I think, that Stefan also mentioned, of industrialization. We need to, if we're gonna put batteries into cars on an industrial scale, we need to also be able to recycle them on the same scale. Stefan, do you have anything to add on that, or?
The answer was perfect. Thank you.
Then another question, which also seen popping up more and more, is the use of data, and how the use of data coming from batteries, coming from the vehicle management system will interact, how we can follow the state of health of the battery throughout the life cycle of the car. How are we gonna manage that within the sector? Is it also one of the focuses that you have right now to how we're going to integrate that data? So not only the physical interface with the battery, but also the data interface. Stefan, is it part of the ERTREC agenda?
An answer on this, because it's absolutely clear, if we want to create a system where we are able to recycle the batteries in a sustainable way, this means that all the actors which are involved need to get the information which is important to do their job, and therefore we need a certain chain of data which are transferred to the different actors. And this we have to organize and to develop. And therefore we need, with the different actors, an agreement on which data are really relevant for which contributor at which moment. And so we need to find an agreement on the type of data and on the standardization, how to transmit this data. Standardization is here really important, and how to do this in the best way that it is accessible for all the actors, and that it can be done in a way that the costs are not so high, because we are in the future talking about mass market, and therefore we have to work on this. From our side, from ERTREC, we can contribute to this by working on the technical issues, but on the regulation issues we are not involved.
Yeah, exactly. R&I can support, but it's not the main shaper of the policy going forward. And what you describe is really a sort of need-to-know basis, like parties need to be able to extract the information that they need to know, but not anything more. Let's see, another topic that has been discussed in previous sessions here at the Battery Innovation Days is the workforce going forward. If we want to take this R&I and deploy it on industrial scale, we need to have more workers. Alexander, being in the university, have you seen an uptake of interest in this field, and do you think it will be able to grow, and what role can universities play to attract new talent into the sector?
Very, very good point, very good question, and something we're very, very aware of at the moment. We have a number of enterprises going on in the UK at the moment in this area, and the one thing that's coming up is there is an enormous skill shortage because the field has grown so quickly and continues to grow. We do see more interest, particularly in areas such as engineering, automotive engineering, and people going into the electrochemistry side in the universities at the moment. I think one of the difficulties that we have in the short term is being able to meet the demand. And to do that, I think we're looking more and more at aligned industries. So, for instance, if you take an example of one part of battery production, such as the electrode manufacture via coating, it's not now the case that you just look at somebody from the battery field. You're now looking more towards people from the printing industry. I think this is something that needs to come together, and there needs to be a concerted effort of taking the requirements of industry and feeding them into the educational establishments, whether it's at apprenticeship level, going right the way through to advanced degree, and making sure that we have the syllabus and requirements matched up with what industry needs.
A very interesting point. I think it was also mentioned in the digitalization session earlier that there they're really looking at people who understand electrochemistry and AI development, which is sort of a Venn diagram, which is unfortunately not too big yet, but we need to work on that, on finding those Venn. Is it also something that you look at from the EUCAR perspective, Luis? How to improve this?
Yeah, we have seen that currently there is a lack of knowledge in specific areas in the automotive industry in general. I mean, I remember that we have moved from mechanic to electric to electronic, and now to software-based engineering, and this is a change that in some cases is being really, really fast, and it's difficult to catch up. And then you realize, as Alexander was mentioning, that there is a need and there is a lack of this knowledge in key industries. And this has to be supplied, of course, or at least find a way to overcome this hurdle, this challenge, this limitation.
Well, looking at the time, if there's still any questions for this panel, people, please put it in the chat now, because otherwise we'll move on to the other panel shortly. Just to end this discussion here. If we look at the main drivers that we saw in the presentation of Stefan, it's a hard question because, as Luis said, we need all of them. But if you can only pick one which is really necessary to make the breakthrough to really get a big adaptation of batteries in the automotive sector, what should it be? Should it be fast charging? Should it be safety? Should it be cost? What do you think, Stefan?
From the vehicle perspective, it's cost reduction. And from the system perspective, it's charging infrastructure. That's it. Okay.
Alexander?
To be honest, I'd have to agree wholeheartedly with that. I can't go against what the manufacturer is saying here.
Well, let's say that there's a good agreement here between R&I, research and industry, and that's the way it should forward. And we're going to discuss charging infrastructure in the next session, so that's exactly then where we're going. Let's see, there's another question coming in. Fire risks are a challenge to solve, so users feel at ease with new technology. So how important is that to convince people? So we can get the cost down, we can give people enough charging points. Do you think that safety is still an issue, or what can we do to what's the research that we can show that we are already operating at quite safe levels? Stefan, I don't know if you have a view on this.
Yes, I tried to start. So people are asking for 100% safety. But we all know 100% is not possible, but near to 100% is possible. So we can take the existing situation with our conventional vehicle. They have a certain level of safety, and the battery electric vehicle needs to be at least as safe as the conventional one. And this is what we have and what we still will keep.
Yeah.
Thank you.
And in terms of future research needs, is it there's lots of talk about which generation of batteries we need to develop, the current generation of lithium-ion batteries, or already go focus more on solid state, or what comes after. Can we still improve on the current generation of lithium batteries, especially in the area of safety, or is it now better to make the move to some the quote unquote next technologies? Luis, what are your?
I think it's it's a tricky question. Actually, I deeply believe that it doesn't matter how mature a technology is, it can always be improved. The question that I'm giving back to you is how much does increasing 1% of the efficiency of already mature technologies costs really? Because if this is a huge cost, maybe we can use it to develop a technology that is still in the earliest stages, because it can have a better benefit in the future. I think that, to be honest, lithium technologies as they are now are completely safe, completely secure. That is fine. We have no problem whatsoever. It's as Stefan was mentioning, they are at least as secure as the conventional counterparts. I see engine vehicles anyway. And we have to continue exploring, because there is no one single silver bullet that will solve the problem. We need different technologies for different applications. And this can extend also to the future needs of batteries outside even of road transport, because there is a need, also for stationary applications and so on and so forth in the future. So I think, and I'm a firm believer of exploring all the possible technologies, and then let's see, who fits best, which fit best for specific applications.
Yeah. Thank you on that. I think that's a good note to end this discussion. Thank you so much for participating, and also thank the audience for all the good questions. So thank you, Stefan, Alexander, and Luis. Good luck with all your future endeavors in making the automotive industry go towards carbon neutrality and fossil fuel free. So thank you so much.
Thank you so much. Bye-bye.
So let's now move on to the next panel discussion. We've already touched upon the point 2-3 times in the previous discussion. So really looking forward to invite the other panelists to this to share their thoughts on this topic, the infrastructure challenges ahead to deploy electric vehicles. For this, we have the following people join us. We have Thomas Limes, Policy Advisor of Eurocities. He's the project coordinator on mobility. So he will tell us all about the city planning and how to integrate this into the urban fabric. The extended stakeholder field that Luis was already talking about. So very happy to have you. We have Joseph Affenzeller, Director of Research Coordination at AVL, and also very active in the 2.0 partnership. So welcome, Joseph. And we have Luigi Lanuzza from NLX to really provide the business point of view, both as producer or operator of smart turning points and electricity producer, and Teni Varfi from EDSO to see what really the grid operator view of all this is. So welcome all of you. To start with you, Teni, it was quite a few times, at least 2 times was mentioned, the grids need to be ready for the charging challenge. Are they? Will they be? What needs to be done to tackle this issue?
Thank you, Wouter. Thank you for having me. This is the question of the moment, as you can imagine. No, the grid were not safe, or they were not resilient, but because, as you can imagine, they were there since forever. So they were not expecting this electrification of transportation to come at that level. We have now studies telling that it will be in Europe by 2030, 7 million electric vehicles. So, of course, what it will mean for the grid to support that. What I know, as we are representing the distribution system operators, they are trying to accommodate and do what is possible to make the grid resistant and resilient while making possible and facilitating the integration and deployment of electric vehicle infrastructure into the grid and network. We learn by experience and by doing. So from what it has been communicated from our membership, they have little experience, bad experiences, let's say, by accommodating that. But still, we need to take into account that the rollout is still upcoming. And it's very little in some countries and very much in some others. Just to take an example, the Netherlands is a typical example of country having a lot of electric vehicles. And that is also the case of Norway. When we talk about that, it has the impact in the grid a lot. Now, what we usually do in order to prevent local congestion, as you can imagine, that will come even in the future more than it is now, it's network planning, congestion management. And network planning is something that it relies us actually to see the forecast of the demand, the load demand, in order not to overwhelm the network and to have the blackouts as the ultimate result. Of course, we do these things as a regular exercise by the DSOs. It is not, let's say, electric vehicle charging specific, but more now in today's in order to prevent that the load gets more than the supply. And just to give you an example, most of the times what we do, if it is for specific spots of charging in a local area, we tend to react by making a cable which is more supportive with a larger station, or sometimes to place a new substation in order to accommodate the demanding load coming from the charging. Now, how resilient are we for the future? Of course, the grids need to be digitalized, and they need to be, smart charging needs to come in more. And we are talking nowadays about the dynamic smart charging. I can develop that further if anybody will be interested, but this is what we are doing in order to accommodate the change.
Yeah. I was already introducing Luigi. Luigi, if you're looking at it from the NLX perspective, because you're not only doing charging, but also developing stationary storage solutions. Yep. Can stationary storage, in this case, help to relieve this congestion?
Well, for sure, I would say. It's something that we, as every player in this supply chain like us, is of course addressing. Especially if we think to do high power charging system in the distribution level grid, which is something that is happening, this kind of installation, and the impact can be important, I think, but the battery backing such infrastructure will provide solution for this, leveraging on the capability of providing fast power when occurred, so limiting peaks, for instance, limiting the needs of empowering the grid, which of course will happen anyway. And I would say also for conventional perspective, this is interesting because finally, if you think to it, a charging system of several HPC, each one of 300 kilowatts, for instance, is finally a kind of B2B installation, behind the meter installation, like we do with other industrial sites, commercial industrial sites. And this can give us some opportunity to also provide service to the grid when it's not needed for the recharging, of course.
Okay, thank you. Yeah, it can work both ways. To stay with you for a little bit, we heard in the previous discussion about this immensely increased demand of energy, of electricity in the upcoming years because of the rollout of electric vehicles, the 35% figure that we heard. In addition to the transition of phasing out fossil fuel-based electricity in the grid and then adding this capacity, will it be feasible? Will we be able to get that capacity up in the next decades?
The question is for me?
Yeah, for you. So
yeah, of course. Yes, it's a challenge. No, we speak as of today of around 12 millions of EVs only for passengers in our roads globally. This number is increasing, of course, we know, and of course this means a challenge for providing infrastructure for charging them. It's interesting to note some numbers for having a framework from a study publicly available from IEA, interesting studies. So mostly the charging are happening at home. Mostly at the private side, we speak about 89% of EV chargers are at the private side, and 2/3 are at the really residential, so B2C sites. Something around 10 million, 9.5 million, I think it was, are chargers installed at home. This number, of course, will increase in the years to come. If our target is to having a green fleet of EVs, totally green fleet by 2050, is ambitious, of course. Then we must think that by 2030, 60% of the fleet of passenger vehicles must be electrified. So impressive numbers of fleets, impressive number of chargers which we need, and this will likely happen mostly at again private side. Of course, we have to take care also of public infrastructure, because not everybody has the possibility to have in his garage the charging system. But we are here and we are addressing this, of course, as any player again.
Yeah, that's a very good bridge, I think, to Thomas here, and talking about having the rollout of, on the one hand, public infrastructure, on the other hand, people having to charge them from their own homes, and find a balance in that. Because Eurocities represents over 200, I think, cities around Europe. Yeah. So how do the cities go about to tackle this massive challenge that's coming towards them?
Yes, thank you very much, and thanks for inviting me. Well, I think it's worth noting as a matter of introduction to know that electric vehicles are, of course, one part of the solutions, the different solutions that cities are implementing to create climate neutral cities, to improve air quality in cities. So it's, for cities, it's really like one piece of the puzzle, but it's of course part of a bigger picture. So what's the general vision and the trends that we see, of course, is that cities tend to reduce the place of car in cities, and they want that the remaining part of cars are as clean as possible. So of course, bearing in mind this vision, how do city plan the installation and facilitate the installation of this infrastructure? Well, there are different strategies on the ground, so there is no one fixed answer. But one thing that we observe in cities is that we see local deployment strategy for electric charging infrastructure being more and more integrated in local mobility strategies. So they're often known as sustainable urban mobility plans. So this is kind of a local plan that more and more cities are developing. So it integrates, again, not only electric charging infrastructure, but also public transport development and new ways to use public space. And I can give you one specific example of how this local strategy integrates charging infrastructure deployment, like in the city of in Stockholm, for instance. Like the authorities, they adopted this, what they call this master plan for electric charging infrastructure. It's actually built in collaboration with different stakeholders, so DSOs, charging point operators, to select the streets where local authorities feel that there is a need and identified a need to have the charging infrastructure, so that on those streets, they are sure that there will be the adequate infrastructure that will be deployed, and it makes also sure that it doesn't contradict with the other cities' priorities in terms of urban mobility.
Yeah, so to keep that mix going and find the optimum between reducing and vehicles and trying to give enough access point to the clean vehicles that do come in. So,
exactly.
Yeah, and is this then being shared throughout your network, or how are the results of these kind of initiatives spread around your?
Well, yes, we see more and more cities, and this is also a part of our work at Your Cities. We try to facilitate the exchange of best practices in different cities, and we also work on projects to make sure that new solution, innovation. Also, we talked a lot today about innovation. Is disseminated between cities. So, for instance, we have a big project called User Chi, which project and which looks exactly at this kind of thing, how to integrate electric vehicle charging infrastructure deployment in these local strategies. So this is really a kind of a global pattern that we see in our membership at the EU level.
Yeah, thank you, Joseph. To come back to you as a representative also from the automotive partnership and to zero on this. We saw in the presentation from Stefan that really integrating the EV infrastructure, also the connection with the grid, is something that's on the 2.0 agenda. Are you also there on this, cooperating with lots of with stakeholders like local cities or the grid operators, or are you really looking at it from the vehicle perspective? Oh, you're muted, I think.
Okay, thank you for the, now I'm here.
Yeah.
Thank you for the invitation. It is clear, alone we cannot solve the problem. It is a must, as it was also mentioned by Stefan and the other, to cooperate and to work together. On one side, with the electricity supplier, with the grid partners, with the charging infrastructure, with the services, as well as clear with the automotive side, and with the end user in cities and on highway. This is a must, otherwise we are struggling also in some years in the future. So there's on the charging system also activities now called Gerin activities, promoting charging interoperability based on AC-DC combined charging system for the future. This is mainly active in the view of standardization and testing of charging system for the future, because if you are coming from the grid, if you are coming from the automotive industry, the charging station, and this is always a lack in the cooperation and activities in this direction. And therefore, the standardization of such system is very important, because today what we have AC and we have DC. In the future, we will need more DC charging stations as AC charging station. AC charging station, we have it at home, we have it in the cities and so on, but we need DC, as mentioned also by Stefan, in particular on the highway, but also some in the cities and surrounding. Not so much, but we need it also for taxi drivers, delivering, and so on, also in the city. For this standpoint, today we have two systems. And the two systems, the question would be, can we simplify this one? And here, standardization and discussing are needed between the OEMs on one side and the charging infrastructure service provider, and investments is needed in this direction. For this, we have clear, it was mentioned before too, the EC published a figure for the deployment of charging stations by 2025, with 1 million in 2030, with 3.5 million charging stations. We from the standpoint of AirTag, Equia, and so on, we are seeing that this charging, if you have charging similar as fueling, we should doubling the numbers. Otherwise, we will not reach the targets. This is clear, depending on the numbers of new registered vehicles, and in particular, if it was mentioned before too, if the truck are coming electrified in the cities as well as a longer distance, then we are running, we have a challenge in front of us in this direction to fulfill the requirements. From the battery side for fast charging, the battery side is today not ready, but not directly ready for fast charging. Here, we are talking about C rates, and you have today C rate at a battery of 1.2 in the range, but we need C rates up to 3, 4. And this is a challenge for the development too, because here the ionon flow, the resistance of the ionon flow had to be reduced to avoid heating and to avoid degradation of the battery health. That is in a simple manner spoken about this one. And from this standpoint, here some promising research was published also some days before. And from this standpoint, I think with other materials, but this is a topic for the future, not for today, not for the next 5 years, for the next 10 years. After 10 years, 2030, there will be a topic, but we need here that the resistance is reduced for the ionon flow, as well as for safety. It was also mentioned, we are looking in this time frame also for solid state thing. Yeah. It was mentioned also charging time. If you have today, it's depending on the kilometers which we wanted to get power on in the car. It is a range of 5 to 20 minutes, maybe if you have 100 kilometers or 400 kilometers for a car. And on the other side, clear, if we are traveling from A to B outside a city, we must plan the trip, depending on the traffic, weather condition, charging points. It would be required to reserve a charging point with the needed power and charging time and cost along the trip. This is requested not only in this direction, but we should went forward to have this in the future, and clear in this direction. Charging point will have storage capacity, and if you are looking forward to get in the future with more and more green energy, stable the grid system, we need storage capacity. The storage capacity, and one of the storage capacity can be also as a charging station to increase here the capacity, and to offer this as a capacity to also to say grid stabilization. This is an idea which is under discussing today, but I think it is needed. The other thing is charging stations. It will be charging station need software, and here also needed to consider kinetic controlled automatic mobility at the level of 4+, as well as it was mentioned too, artificial intelligence to control everything in this direction and to get a better result as it was in the past.
I want to quickly pick up on the point of stationary storage at the charging stations that you mentioned, Joseph.
Yeah,
because that's something that could be very interesting as well. And there's a question as well in the chat from Yosu Sendoya. Are there any services actually that if vehicles might be able to either deliver back to the grid, or we have stationary storage at the charging point? Will there be additional services that can be provided? Luigi, do you
First of all, the first question, vehicles or stationary storage coupled to charging system? I would say both. Of course, with different usage. Of course, if we have, again, a battery integrated in a charging station, it's an easy, let's say, pardon me if I say easy, job for the battery, because finally what changes the load in this commercial industrial site. No? So the forecast of the load, the forecast of the charging, this is what changed, but for the rest it can be the same services, so reserve, frequency control, this kind of services can be done in parallel, provided that we have always the available capacity for the cars when they will arrive, when they charge. No? When speaking about the services from the cars itself, is a bit more complex. It's a matter of interoperability, I would say, which can be improved. We have a lot of example, but still I think there is something to work on with car manufacturers, with the infrastructures, with also grid operators. But it's something to work, because finally we will have millions of 100 kilowatt hours packs available when they charge. So of course it's a no-brainer. We will need to use these batteries as well.
Yeah. So maybe we can pivot towards Zeni for a second on this. Then, do you see, like right now it can be a struggle to integrate all the charging points and the renewable energy needed to deliver power to them? But can you see a future where actually having all those different sources of energy storage throughout the grid can be an advantage for the distributors?
For picking up on this, I would say what is interesting in case of electric vehicle charging infrastructure is the thing that it comes with challenges, but it provides solution in itself. Yeah. Why I'm saying that, just to pick up on the last reflection that it came from Luigi, there is now, it is a possibility. In the past, it has been grid to vehicles. Now we have reversed the order. We have vehicles to grid. It's one of the technologies being used and developed recently. Not recently, it's been years, but now it's getting up front, let's say, when you can not only take from the grid the energy that you would like, but you store in the battery of the electric car, and then you put it back in the grid when needs are. So that's how you use one of the renewable resources you have. That said, you can combine that with other wind and solar power in order to still make a connection system where anytime there is need of the grid and there are a lot of demands, you can use what is around. Now, the problem with the renewable resources is that they are volatile. So you had the system of inertia in the past days when you have this system to make sure that there is a balancing exercise between the demand and supply. Now that does not work anymore. We want to switch from it, and we are moving toward the renewables. So more renewables you have penetrated into the grid, the better is. Now, I have to say everything that the charging infrastructure brought to us has been disruptive, has been challenging, but I see only a good future if the grids in the meantime have the necessary let's say, financial support in order to invest in the grids to make them reliable. Because whatever renewable resources you will put in there, if the grid is not reliable and it is not solid or robust enough, will not actually make this complementary and connection system. So I would say we are moving towards a positive kind of forward-looking outlook. And I hope it will stay as such, or it will be better than we expect. But I would say that without the grid investments, that will not be possible in the long run.
Yeah. Thomas, to follow up on this, is there some kind of? I know a lot of municipalities are looking at charging and as also a way to direct the flow of traffic and to also have an extra point of income if they place them themselves as a sort of public service that people will pay for. are there new business models also coming out of this new trend that you see?
Well, there we see some business models emerging. One of them being, for instance, like to lease parking lots together with the charging infrastructure. So we see a lot of kind of bundled services coming up in different parts of in cities in Europe. And of course, new services coming up, like for instance, again in the Usergy project I just mentioned before, we are working on an app to book a charging spot, to make sure that whenever you need to use on-street charging, you can find a spot to charge in the city. So there are a couple of business models that are emerging in the city. Of course, it's still, let's say, in the inception phase, even if you see more and more of these services emerging. So that's the role of the cities also is to facilitate this kind of services, and to make sure that they cater to the needs of different users in the city.
Yeah, maybe this one for I don't know, either Joseph or Teni. Like, is there any? Joseph already also talked about that people need to like book a place for their charging system. This is the same what Thomas now saying. That kind of, I think that kind of information could be very useful for the grid operators also to sort of predict the energy demand over a day. Is this something that you look into as well, to share this kind of data and share your research on this, Teddy?
Yes, I start, and then he can complement. And what we do, when I mentioned at the beginning network planning, that's exactly what we do. So there is a regular exercise of network planning that relies on specific parameters. And those parameters will relate exactly to what Thomas mentioned, that you need to have how many charging stations, how many charging points or spots they are connected to that, what are the demands, what is the density of the population, that local geographical kind of area you are trying to accommodate the demand. So that really helps. The better is the forecast, the better we can predict, and we can actually upgrade the grid. So this is one of the challenges also the DSOs are encountering, because we have uncertainty most of the times, or sometimes the localities, or when they are local projects, do not communicate necessarily with the DSOs, and that causes obviously a problem of grids, because you have overloads and you don't know where it came from, why the data was not correctly and accurately transmitted to us. And also there is a difference between smart charging when it's quick and when it's long, like if it's fast enough or not. That will make also a difference in the demand. So indeed, and for the longer yearly kind of planning, development planning that DSOs actually perform, you need a lot more. You need also the behavior of the citizens in terms of charging points, where the apps are clickable, at what time the intensity or frequency of charging is made in that specific location or country or city, whatever you would like to. So everything of these parameters will help us to do our job better, but also to accommodate the deployment of electric charging infrastructure, for sure.
Yeah. So, Joseph, what do you think that what areas of research and innovation can help to get this data to the? Do we need to invest more in artificial intelligence or the interface? Where do you see how we can help the grid operators?
Who should answer?
You.
Yeah, I think if I can answer this one, we need both. We need the information. We need the information. Clear today. We have. It was mentioned before. B2B. The battery today, based on the expectation of the lifetime, it's not ready to have B2B or battery to cars and so on to work as a storage place. But in the future, we will have it. the information is needed, in particular also for the supply system in a region. I think, as it was mentioned before, it is a region had to handle the service, and the vehicle and the charging is one of the consumer, as today is an industry or a household or a house. And this had to be integrated and managed in the right manner, and also to give information what is possible and what is not possible. So it is a new approach where everybody or every sector had to work together to realize the challenge for the future.
Yeah, very clear. We're in this together, all of us. Let's, as a final thought, just you can, if you can highlight one point that we need to get right in the next 5 years to overcome these challenges, what do you think it will be, Thomas?
Thank you, Wouter. I think what's important to bear in mind also from a city's perspective is the issue of public space. It's often not really mentioned in the debate on alternative fuel infrastructure. And just to pick up on what Stefan has said before, we need I understand we need the adequate infrastructure, but also we need to make sure that this infrastructure is used and takes as few public space as possible, especially in cities, and to make sure that we don't have an oversized network at the end of the day that no one would use.
Okay, they're very clear. Luigi, what should we get right before to get charging them?
Well, my points, I would say, let's work together. I mean, all the institution and also the private side, to push to sustain this effort we will need for enhancing the infrastructures. When we speak about the funding needed, we need to work all together. Yeah. Also, when we need about the authorization, which is something that is impacting a lot the time to market in our cases when installing our infrastructures. And also the point I just heard about the usage of charging point is something that we do see, and there are also best practice worldwide. We see, like in California, there is a tax credit for, the energy for recharging cars is eligible for tax credit. This is a kind of incentive for using really the infrastructures.
Yeah, very good. Tenny, what do you think is the one thing to get right?
Very short. I would say electrification coordination strategy. Yeah. Because for the first time in history, all the vectors and all the actors need to speak to each other and to coordinate with each other. Transport and electricity, they were way too separated. For the first time, we need to sit together and to see how we can coordinate and in order to achieve better climate neutrality.
Yeah. Coordination seems to be the red thread here in this discussion. Very, very good to see that everybody agrees on that. Joseph, what's the one thing that we need to get right?
From my side, as you can expect, coordination or cooperation is a must. And if we are not, we need it in this direction, as well as exchange. It was mentioned, exchange of data in this direction, not only on health, also about the behavior of the user in a region. And such a system had to be developed. That every user, if it's industry, householders, or metro or vehicles, have to be managed with a specific service. And this is a challenge for the working together. Otherwise, we want it not to fail.
Yeah, okay. I think that's the very perfect ending of this session. I thank you all for your participation. It was very enlightening to see all your different points of view, but we converge on the same message. Thank you, everybody who has been watching this session. I hope it was instructive for you. It's now time for get some coffee, take a break, do some networking in the app. Come back at 4 o'clock. We have the presentation of the Battery Young Research Award. I got to see the presentations of the people who applied, and they were very high-level research, and the winner is really top class. So please join us for that. We also start again tomorrow morning at 9:30. Amongst the sessions is the sessions hosted by BEPA, where we present the topics that are on the table for the Horizon Europe work program 23-24. So if you're interested in what we are doing in the battery research and innovation sector within Horizon Europe, please join us for that. And it's going to be an interactive session, so you can also tell us what you think should be the priorities. So everybody, thank you so much, and enjoy the rest of the Battery Innovation Days. Goodbye.
Thank you.
Goodbye.
Goodbye.